Hello guys, okay, so let's just proceed. Now we're looking at this particular graph where we say that we want to get to finding the gradient at point B, and we're starting off with the line AB, which is a poor estimation of the gradient. But it does give us the 2 points that we need. So we did start with this kind of a setup where we had our change in X being like this, and our change in Y being this one here. But we know for a fact that the only way we can be able to move line, I'm going to call the tangent in red, the red line, which is a tangent, I'm going to call it BT. Okay, so we want to get AB to be BT because BT is the tangent, right? But remember that the tangent only has one point of contact, and it'll be difficult to be able to use just one point to be able to find the gradient. So what we do is that we start off with the line AB as an estimate, poor as it may be. But we then try to move the point A, all right? We try to move the point A further up the curve, approaching B. Because as it approaches B, the line AB also approaches the gradient BT. Let me show you how this works. So we're starting off with the line AB, and if you notice, this is the line A. Oh, let me use a different color. A, B, and let me call this this one now the new line CB. When we're moving closer, when the point A goes up the curve to where the point C is, you will see that the gradient is really becoming steeper. And similarly, A, let me call this B, A, C, let me call this D. As you can see, it's becoming even more steeper until eventually, when you have a series of lines, A, B, C, D, E. So you will notice something that's important about this movement is that as the point A moves up the curve to C to D to E, and as it approaches B, the gradient of the line AB approaches the gradient of the line BT. BT, which is the red line, is our ideal line, and we want to get as close to it as possible. So how we do this is we start off with this simple diagram that we have on there, and we say that because from our formula, from my initial formula, which I'm just going to grab from here, okay, just going to come and put it here. Okay, it fits. Right. So this is our initial formula, and we want this to use this formula in establishing our derivatives. Now, going back to a normal color, okay, that's correct. Now, what we're saying is that as A moves from where it is to where C is, notice what is changing. We initially had this change in X, but notice now that what's happening to the change in X there. Similarly, with D, notice what's happening to the change in X. Similarly with E, notice what's happening with the change in X. So what's happening is, what the scenario we want is for AB to be as close or as similar to BT as possible. The only way we can do this is if A moves up the curve and it approaches B, and as it does so, we notice that what's really changing is the change in X is becoming smaller all the time. And as the change, excuse me for that, as the change in X becomes smaller, our gradient of the line becomes closer to the tangent that we intend to the perfect tangent that we intend to use. So we come up with this fact that as change in x approaches, as you can see, it's becoming smaller. So as it approaches 0, then what happens? The gradient we begin off with as an estimate, the gradient of line AB also approaches gradient of line BT, which is our tangent, which is what we want. Now, how do we normally show this statement in mathematical terms? How do we normally show it? When we say as delta x approaches 0, we write this as delta x approaches 0. Similarly, how do we write gradient line MAB, line AB approaches gradient of line that? We again write it as, we can simplify and say grad AB approaches grad BT. So how do we use it along with this information that we had from the beginning? Let me just bring it down here. Okay, we wrote this before, and we say that this was the gradient of AB. But to get it to be as accurate as possible, then we want this scenario to take position, that the change in x, or the difference between the x coordinates of A and B, to be as small as possible. And that way we will end up with this kind of a situation. And as your graph approaches, as your points approach B, then your gradient also approaches the gradient of the tangent. So how do we write this here? It becomes that, just start it off from the limit as a change in x approaches 0 of f of x 2 minus f of x 1 over this is equals to the gradient BT. Different textbooks, examples will show it or ask it differently. Some don't use x2 and x1, they actually use an h for the delta x. So don't be swayed by differences in notations. The concept is still the same. So in essence, this is your differentiation from first principles. And I'm going to show you in the next video how to use this.